Thanks for the opportunity to be here. Again, my name is Schiavone, and I'm with University of Maryland Extension. My home office is actually in Washington County, so I had a little bit of a drive this morning in the rain. But if you are ever out in the area, you're welcome to stop by for a visit. Of course, I'll provide my phone number and email if you want to reach out to me after today's program. I'd be more than happy to answer any questions regarding some of the energy stuff I'll share with you today, as well as, we have a group here from Solar Energy Consultant, Sunrise Solar. Sorry. I dabble with some renewable energy systems. I'll point you to some of those resources that we have available for solar energy and geothermal and other technologies. But primarily, I'm going to talk about it's not quite as appealing as like looking at pumps and motors and lighting, fans and ventilation. That's not quite as appealing, but it offers a much better return on your investment. We'll look at some of the savings that you can do with some of these retrofits to cut down on your costs. And as a bit of a disclaimer, I'm an energy specialist. I'm an engineer. I am not a poultry grower. So if I say something about a particular pump or a motor or something that just doesn't make sense for your operation, feel free to chime in, interrupt me, and let me know, if I'm off base. So yeah, absolutely. So I can tell you something that makes perfect sense on an energy standpoint, but my experience in poultry operations is just dabbling with energy audits and assessing where energy use goes. My engineering experience is in fruits and vegetables. So just take that with whatever I say with a grain of salt, but I'll share with you some of the cost savings that we see across the board. Share some of the resources that we have before I touch on cost savings for your farm. Some of the resources we have, the best place to get those is on our extension website, extension.umd.edu. You can click around there and find anything related to energy on there. I'll point out a couple things. If you go to the website, it'll direct you towards a video channel on energy topics. So you can look at workshops like this that are recorded. You can look at some tutorials on how to save energy in your home or on your farm. There's a lot of practical solar videos on there as well that are quite popular. So there's a number of video resources, publications, and then the one additional thing I'll point out is we have a newsletter that goes out on energy savings. So I sent the spring issue last week or so. You can look at that on the website. It has a list of what I think is important is incentives and grants to pay for some of these things like LED lighting and other things, whatever you might be interested in, solar grants and things like that to offset some of the costs. So that newsletter goes out. I email that a couple times a year. You can go and look at that. It has some recommendations on energy savings. It has a list of programs and workshops that we offer through the extension service as well as other providers. So if you're interested in any of those resources, again, you can get them on the extension website, extension.umd.edu. Energy use across the board is highly variable. Obviously, it depends on the type of operation. A cash crop grower like corn or soybeans or something, they have a lot of indirect energy in terms of fertilizers and other chemicals, pesticides that come from fossil fuels. But being that most of us are not engaged in those kind of cash crops, we're looking. So, poultry, your major energy expense, as you know, is electricity and fuel, propane for heating and everything. So, but on average, and this is just average because there is a high level of variability, I think on average, if I look at this, poultry is about 15% of your budget goes towards energy. It could be much higher, it could be a little bit lower than that. This is just average. It really just depends on a number of different factors, and I'll highlight some of those as I point out some tips here. When we look at the electricity side, so I'm going to primarily spend most of my time talking about electricity and fuel. That's the biggest energy expense for poultry growers. What you'll see is, when the temperature is low, this is outdoor temperature on the bottom of this graph. When temperatures are pretty cool out, it's a nice and cool day out, you're going to have base load energy use. You're going to have all your you're not going to have fans. You're going to have, in your base load, you're going to have all your pumps and motors and anything running like that, traditional equipment that runs every day. But when the temperature gets hotter, of course, you're going to have this linear increase where your ventilation comes on. So a couple things I'll just point out. One, when you're looking at your annual energy use, you have to capture that seasonal variation as well from the extreme winter to summer temperatures. You're going to have different energy use. You can see that linear increase when the fans are running and all that cooling is happening. That's going to be your variable load, and that's typically in the hottest times of the year for electricity. So you have to capture that when you're looking at your overall energy use, and I'll give you some tips on how to do that in a minute. But just to understand, don't just look at a snapshot of what energy you're using today, okay? You want to look over a period of time, and you'll see some of those different variations. For the fuel use for your propane, it's exactly the opposite. And I'm sorry if I'm blocking the view of some of this, but you'll see, fuel use is quite the opposite. At the low temperatures, you're going to have a drop in you're going to have a drop in fuel there as it gets warmer. Once it gets to about 50 degrees or so, is that about right? You turn the heat off. I don't know. It just depends on the efficiency of your facility, for one, among other factors. But once you get to about 50 degrees, it's going to level out, and you're not going to really use the fuel anymore. So again, look at the whole temperature and all the other conditions. So every type of farm is different, but every poultry operation is also different. This is kind of a snapshot average of poultry farms in the region. Most of your energy is going to space heating, okay? That's the same for any residential or commercial system. Heating up the room and keeping a room warm in the winter is a big expense. So that's the biggest thing, and ventilation is kind of secondary to that. So I'm going to spend most of my time this morning talking about tips for space heating and ventilation, your pumps, motors, and other things, feeding systems, and watering. That's to a smaller extent. So if I have time, I'll touch on those other topics. But if you're looking to implement any kind of energy savings, you want to prioritize those big areas first, and then you'll get your better return on your investment. Way to kind of assess this is to look at your energy use index. So kind of where you stand in comparison to other farms in the area. One of the most basic ways to do this, and I'll just go through this very simple algebra here. It's just two numbers. You're going to take your energy use, which is in kilowatt hours. So you get that from your chop tank bill or Delmarva, whoever you're with. You can go to your bill, look at the 12-month average. It'll say on your utility bill how many kilowatt hours, kWh, you used. So you'll divide that number by how many birds you have on the farm. Okay, it's as simple as that. You could do it in other ways, but this is a good estimate of your energy use index, and you can compare it to the averages. So on this scale to the right, you'll see on the lower range, poultry operations might be about an index of about 2 up to about 6. So the lower number is better. That means you're more efficient in terms of your energy use. So if you run these numbers yourself and find out that you're about a value of about 2 in your energy index, there's not a whole lot you could do economically. If you're down at about 2, you could certainly invest in some kind of energy system or energy retrofit, but it's not really going to be a good return on your investment. But if you're up here, middle of this range, around 4, or, of course up near 6, you want to look into some of the things I'll share with you about heating, ventilation, lighting, or other systems like that, and try to bring your number down a little bit. So it's a good estimate. A couple trends here before I point out some tips. I'll point out these trends. Electricity prices are averaging about 2% increase going back, 30, 40 years. You're looking back to 1990. It's been some fluctuations and everything like that, but roughly 2% escalation in electricity prices in Maryland. I'm sure within the past couple of years, everyone's seeing prices go up, depending on your rate structure and provider. But that's kind of averages across the board. So you got to kind of take into account long-term with any kind of decision you make. And this will go beyond what I can cover in today's program. But if you're looking at any energy system, a retrofitting system, switching something from gas to electric, or solar energy, whatever kind of decision you're making, you want to consider the future prices of electricity. And so that comes with some forecasting, but this is kind of an average projection. And again, the other thing I want to point out is consider if you're on a residential or a commercial structure. So if you're residential, and some of you might have more than one meter. Does anyone have more than one power meter? A couple of you. So, look at, some might be residential, some might be commercial, but if you are looking at your residential meter, it is going to be charged per kilowatt hour for the amount of energy that you use. The difference with a commercial rate structure, if you're paying a commercial rate structure, is you'll also get hit with a demand charge, which is based on a peak demand. So if you turn all of your pumps and motors on at the same time, you're going to hit a higher peak and get penalized for that and pay for that. So I'll talk a little bit about that as well as a strategy to save money by staggering the operation of some of your equipment so that you'll see some savings there. I'll give you an example of that later. But that's, again, only for commercial rate structures. If you're residential, you don't have that demand charge. You're just charged for the actual amount of energy for a residential rate. Anybody doing cage-free or lower density growing? So yeah, with the cage-free operations, this usually have a higher index. And I share this information with any program that I teach, is focus on the energy measures that are going to give you the best return on your investment. Okay, I would never advise anyone to go out and buy an expensive solar power system before they've done some efficiency. Okay, so what I'm sharing in this illustration is at the bottom of this triangle is focusing on energy audits or energy assessments. Has anyone had an audit done on their farm? So that's good that a couple of you have done that. If anyone is interested in that, we have some people here today, and I'd be more than willing to provide references for audits. But if you have a formal energy audit done on your farm, they will generate a report for you that's investment grade report that you can know exactly what would benefit you in terms of your energy systems, what would be the first priority. So that's obviously a good place to start, is with an energy audit. You could also do a self-assessment. Of course, it's not going to be investment grade, but I have some resources if anyone's interested in walking around on the farm, or I'd be more than happy to connect with you if you're looking for an impartial person like myself. But any auditor is going to be impartial in providing a good assessment of where your energy is being used. But what you do with that information is then you start implementing energy saving measures, starting with conservation. You're working your way up that diagram there. Conservation is like turning the lights off when you leave the room. So when we leave this building, we'll turn the lights off. That didn't cost us anything just to flip that switch, but we save money instantly. So conservation is your best place to start. You'll see that reflected in some of the information I share with you momentarily. But that's where you want to start. Then efficiency. You might want to invest in things like efficient light bulbs, LED lighting, a little bit of investment, but a good return on that investment. Time of use management in red there is, again, if you're on that commercial rate structure where you're getting a peak demand charge, you want to stagger some of your equipment so that it's not turning on at the same time. So we'll talk about some of that load shifting. And then, and only then, should you look at a renewable energy system, wind powered, solar, whatever it might be. Those are more expensive technologies. There's a lot of incentives in place for renewables, as there are with these other efficiency and conservation. But renewable energy systems can come with a heavy price tag. Okay, so again, let me give you some tips and tools on some cost savings for your operation. Again, being that heating and ventilation are the biggest energy expenditures for a poultry operation, I'll talk about some of that. The graph I'm sharing here is just to show some of the variability. I think this is 48-inch fans. There's some variability. The top line here, this is airflow on the left-hand side, and the static pressure, just how they measure the resistance of the flow. So that's how they measure fans. You can find this information from the manufacturer of the ventilation fans that you have, whatever you might have. some of the best fans are operating at higher flow rates and static pressures. Some of the less expensive ones operate at lower airflow and pressure. Obviously, you want a better airflow pump, but the average, will be somewhere in the middle. But I'll share where you can get some of this information, and hopefully that'll make a little bit more sense. You can look at this BESS website from the University of Illinois for information on different types of fans. They'll give you a number of different pieces of information on airflow and the efficiency. And airflow is measured in cubic feet per minute, but what we want to look at it as well as the efficiency. Efficiency would be per watt. So how much airflow can you get for the amount of electricity that goes into the fan? You want to put as little electricity into it, wattage. Electricity is measured in watts. So you want to put as little electricity into it as you can and get a lot of airflow out of it. So that would be the efficiency of a fan. So if you want to review one of these resources here, this BESS website from the University of Illinois, they do field testing on different fans and provide pretty good information on that. In terms of the efficiency, I just pulled some values here. And the higher that this efficiency ratio is, a VER ratio, the more efficient your fan is. And we'll see some savings associated with that. This is just some more data. I'm not going to spend a whole lot of time on this, but just looking at different size fans here, 24-inch to 48-inch. You typically, if you're working with a 48-inch fan, you probably want at least a value of about 18 to 20 or more in terms of the efficiency to see some cost savings. If your ventilation system's working fine, I never recommend replacing an operational system with a more efficient system. It just doesn't make economic sense. If any equipment you have is on its last leg, then you would be looking at a more efficient fan or something like that. But don't get me wrong that I'm saying throw out a good working piece of equipment and buy something more efficient. That's not going to benefit you. Only invest in something that's going to replace something that's broken or needs repair or something like that. But it's a case-by-case basis what's going to work. But if you are looking for a new fan, if you're in the market for new ventilation or curious about what your current ventilation systems are, you can go to that BESS website. You can look at the manufacturer's specifications for the equipment you have, and you can see what the VER, that ventilation efficiency ratio is. And it should be up, again, for a 48-inch fan, you probably want 18, 20 or more in terms of the VER. Now, when you're comparing two fans, so this is a comparison of two fans, fan A and fan B. On the figure on the left, you'll see that the airflow for fan A and fan B is pretty much consistent, okay? So if you're looking at airflow only, of course, we want more airflow to remove ammonia and other things like that, but if you're only looking at airflow, there's not much difference between fan A and fan B. And again, what I want to go back to is this VER, the efficiency ratio. This is on a per watt basis. So on the right-hand side, you see this is the efficiency. It's a cubic feet per minute airflow divided by the wattage. So that's where you're really going to see the difference between these two fans is when you look at a per watt efficiency basis. So again, here we see at a static pressure of 1/10 of an inch of static pressure, we see fan B is actually outperforming fan A now. So if you're looking at the difference between fan A and B, fan B is more efficient because of that VER, that ventilation efficiency ratio. So again, you want to pick a higher ratio fan, will provide some cost savings. I won't go through this economic sheet, but again, comparing those two fans, fan A and B, and these are kind of arbitrary prices. I just kind of made these up. But for fan A, I just said it was $500. I gave it a 50% off coupon for fan A. Fan B, I left it $1,000. Okay, so if you bought a number of these fans, you might say fan A, because it's only half the cost, is better, but remember, fan B has a higher VER. Okay, it's a higher efficiency ratio. As a result of that, the operational cost for fan A comes out to an additional $8,000 in electricity costs. Okay, so even though you saved money by purchasing fan A, you end up spending a lot more on the electricity over a 10-year period. Okay, so it's kind of a long-term strategy. And again, some of that might come into the electricity costs, and this is with a fixed electricity cost. But if you had that 2% factored in there, that 2% escalation in electricity, every year that price in electricity is going to increase 2%, you're going to be spending a lot more than that. But again, that's the importance of a higher efficiency fan. You also, when you're looking at the specifications for a fan, whatever resource you have, if you're looking in the owner's manual specification guide from the manufacturer, make sure that you're looking at it with all the components on it. So that BESS, University of Illinois resource I shared with you, that lab actually does field testing with the equipment under actual conditions. Okay, so you'll get a true assessment of how that fan's going to operate on site. And this isn't so common anymore, but some manufacturers would give you this bare fan data without the shutters on it, without anything like that. It's not realistic conditions, okay? You have to have those shutters and things in place in order to see what the true efficiency of the fan is going to be. So make sure that you're looking at the correct data, because you see the bare fan actually makes it look like it has a higher airflow than the with the shutters in place. So make sure you're looking at good field assessment for the curve. And most specification sheets will give you this kind of curve data. Just make sure it's not with the bare fan. Make sure it's with those accessories in place. You're looking at different types of shutters. I would say the butterfly shutters are much more efficient. There are external shutters, which are kind of the lowest efficiency. Better efficiency is with the shutters on the outside of the fan. So you can go and, if you don't recall what yours look like or something, or you can go and take a look at those, but see where the shutters are. If they're on the inside, you get typically a 10 or 15% improved airflow. So I'd recommend looking at interior fans or those butterfly shutters. And then the discharge cone is also a benefit as well. Having those discharge cones on there will often provide some cost savings. Really depends on how much investment. You have to compare the investment of the equipment to the energy savings long term. Again, that goes back to that example like that fan A and fan B. It looked like fan A would save you because you had that 50% off coupon, but the fact is, over a 10-year period, fan A cost you a lot more because it wasn't as efficient. So you got to look at that, the investment versus the operational cost. There's a number of things I could say just about cleaning things, but I won't go into all these details. But check the belts on any of those systems. Make sure they're not worn or broken down or anything. Make sure the belts are sitting on the pulleys in a high position. Clean the shutters and everything like that. If the shutters are not clean, they can get weighed down and they won't open. You won't get good airflow through them. So clean those at least a couple times a year, and that'll improve efficiency as well. You don't really think about those things as often. I get a number of phone calls from people that are interested in solar technology, but they don't think about the simple stuff like this that'll make a big impact in their monthly bills. Just by good maintenance. Another thing is just kind of the environmental control and management of your operation, and how you manage things can make a difference. In some cases, you might be losing heat through the ventilation system. So sometimes there's a tendency to shut that ventilation system off so that you don't lose that heat. The problem with that is your ammonia is going to build up and your moisture is going to build up, and you're going to end up with bird productivity impacted and a number of other factors. And then you're going to have to work much harder after the fact to regain that ventilation, to remove that moisture and ammonia. So it's better to kind of stay on top of things. Again, I'm not a poultry operator. I do recommend you monitor ammonia and moisture and things like that, and maintain proper recommendations on those levels. But don't get behind on something trying to retain your heat, because you're also going to retain moisture and ammonia and other things. I'll just share some of these images here, these infrared images from University of Georgia, just to show what we can see in terms of the heat distribution in a poultry house. and you can see what you want is this uniform heating along the floor. Okay, so the lighter colors, the white, the yellow, the orange on the floor here is a good heat level on the floor. You'll see the walls around the side walls here with cooler temperatures. I don't know if there's good enough insulation in there or not, but you're typically going to have those cooler temperatures along the side walls, and you want all your heat to be focused here on the floor. So that's another thing to consider, is where your heat is going. Okay, so on the left-hand side, you'll see the heat's not getting to the side wall here where you have some birds. So that's going to be performance issues that you're going to have. It might be some infiltration or the insulation along the side walls. This is going to be common with curtain walled systems. Does anyone use curtains on the side, or is it all closed? So, you know, if you do, you probably have some cooler regions along the side that are a little bit harder to manage without a hard side here. But this is more what you want, is uniformity across the floor. With the forced air, I don't know if anyone still uses forced air, but the problem with that is all the hot air goes to the roof. It does you no good by heating the roof. And that's why the industry is kind of using radiant heat, where you can really focus it, again, right where the birds are. Okay, so if you are using forced air, it's much more expensive using a forced air system. I'd consider replacing it if it's aging, but I'm not sure if anyone still uses that. But radiant heating is by and large the best way to go. You could also perform a static pressure test. They do offer small devices like this. You can buy them from a number of different retailers. You can probably get them on Amazon. But the static pressure test, you close everything down, keep it airtight, and then this allows you to see where you have air leakage. And you're going to identify where the air is leaking in and out of the building, and then seal that up. And so you want to aim for, you know, with a 36-inch fan, you're going to aim for a lower, like a little bit more than 1/10 of an inch of static pressure. With a 48-inch fan system, you're going to aim for a little bit higher, like 1/3 of an inch of static pressure. But the static pressure test, again, that's related to how fans are rated, but you want to see how much resistance there is in airflow if there's air leaking somewhere. So that's what that's all about. So you can buy a device like this. You can perform some assessments and then go around and caulking and sealing everything to stop that air leakage. Of course, you don't want to have a poultry house as tight as a modern home, because you're going to have that ammonia build up, and you just have to make sure you ventilate and take care of everything like that. But monitor ammonia, monitor the moisture. You can do some static pressure tests and assess from there. So I shared a bit about heating, ventilation. I'll share just a few key things on other things like lighting real quick, but I'm not going to spend as much time on that. I'll just touch on lighting. And when you're looking at lighting, you're looking at brightness as one aspect. So this is actually from a regular light bulb at Home Depot I looked at. This is the brightness of this bulb is 800 lumens. And so that's typical. What you're looking at is the brightness of a light bulb. And again, I'm not saying anything about the recommendations for poultry operations. You'll have to look at the specifications for what's recommended for your operation, the hours of lighting and everything like that. But I'm just sharing you how light bulbs are rated. You look at the brightness and you look at the wattage or the power of the bulb. If you remember the old incandescent bulbs that are pretty much phased out now, they were like 100 watts per light bulb, and it's stamped on the bulb itself. The LED, like this LED, as an example, is only 8.5 watts. LEDs use a lot less power or energy. And so what you do with these numbers is you take the brightness, lumens, divided by the power in watts, and that's the efficiency or the efficacy. So you would divide, in this case, 800 lumens divided by 8.5 watts, and that gives you the efficiency of the bulb. Okay. Again, just like we looked at the efficiency for fans, you want to get a higher number is more efficiency. So I highlighted just on average an LED light bulb has an efficiency or an efficacy of 119, where a compact fluorescent is down at like 70. Okay, so LED beats out most of your metal halide and every other bulb. LED is by and large an efficient light bulb, and the cost is pretty low. I ran some numbers, this is from a residential program I did recently, but I ran some numbers on these lighting systems, looking at the difference between metal halide, CFL, and LED. Again, LED is the highest efficiency, so it results in the lowest operational cost in terms of electricity use. Okay, so it took, just in a simple example, metal halide took it was about over $200 a year to operate that metal halide lighting, where LEDs only cost $54 in electricity use. So it does benefit you. If you have a good deal on LED lighting, you can look at that. But I'll mention some of the incentives later. Again, just follow recommendations for the lighting for your poultry, but you're not going to be looking at that bright of those examples that I just shared, but just follow the recommendations. The same standards apply. It's lumens over watts gives you the efficiency. Cleaning the lighting is also highly advisable. I think the average recommendation is like every 4 months or so to clean the lighting systems. It depends on how dirty they get. But if you clean them every couple months, then I think it's estimated that you can get away with about 15% fewer fixtures. So, installing all those fixtures has a heavy price tag with it. So the less fixtures that you have to install, the better off you are. You just have to clean them to get that same light level out. They get a lot of grime on them, and being able to clean them. So look at different how convenient they are to clean and things like that. With your feed water systems, of course, it's just your motors and things like that. Look at highly efficient motors. Again, if you have a working motor, don't go and replace it necessarily. But if you're in the market for a new motor, look at the high efficiency motors. Replace those. The other thing I'll say, going back to what I said about those commercial rate structures, if you have a peak demand charge, shift some of your loads, off 15 minutes, so that you don't want all your motors turning on at the same time. So in this example here, we have kind of every time one of these red lines spikes is when the motors turn on. So if all your motors turn on at the same time, you're peaking at about a maximum value on this example of 45 kilowatts. So again, if you're a commercial rate structure and you're paying Choptank or Delmarva, whoever you're with, if you're paying a commercial rate structure, you're going to be paying some factor of this maximum use up here. So the idea with shifting your loads is to shift some of your motors to operate at different times. Put them on a controller or schedule them, or manually turn them on at different times, whatever it might be. But if we're able to stagger that by 15 minutes or so, this green line now is a much lower demand. We're down now at 15 kilowatts. And so you're not going to be billed as high of a rate on a commercial rate structure. So again, that's the benefit of just scheduling things in the day will save you quite a bit. With the watering system, biggest thing is to make sure there's no leaks in the water. Again, the same thing applies to the motors and pumps and stuff like that. Variable frequency drives. Don't go with standard on-off at 30 and 60 psi or whatever, but get something that can more precisely control pressure for that watering system. But the biggest thing, again, is any leaking water is going to cost you. Same thing goes with any irrigation or anything like that. That's the bulk of what I want to talk to you guys about. I'm not going to get into the solar stuff here. I thought I might share that, but we do have the team from Sunrise Solar, so I'll defer to them. But the final thing I'll point out is with all of these cost-saving benefits, there is investment obviously included in it. Some of the things like better conservation and fixing your watering system, the leakage or something, that's pretty easy to fix if you have the time to do it. But some of the more bigger investments, there are incentives and grants and things available. I'll point to some of those real quickly. But again, you'll find a list of these in the energy newsletter I mentioned. I'll share that with you again in a minute. But a lot of the incentives have been increased and improved, and some have been revitalized through the Inflation Reduction Act that the federal administration passed last year. A good place to start is, and we have someone here from Choptank, they could probably talk more on this. There's incentives through Choptank for residential. I'm not sure what commercial programs they have. Again, I'm from Washington County, so I don't know exactly what they have going on here lately. Delmarva, reach out to your provider and find out what incentives they have. They can often help you save on some of these types of things we talked about. The USDA Rural Energy Program as well has grants and loans available. It's increased to 50% of the cost for these things. They cover both efficiency things like LED lighting, fans, insulation, all those types of things that you might want to invest in. This can be a huge game changer, so you don't have to put all that money out yourself, as well as the renewable energy side, so things like solar and geothermal. There's a number of other programs. Again, you'll find this information in the newsletter. There's a number of other grants out there in the state for solar energy, wood energy, for burning biomass or something like that, and a number of other resources. Again, don't feel like you got to write all this down. If you want more information, I'll share it. Yeah, here. You can go to the website, the Extension, University of Maryland Extension website, extension.umd.edu. If you click around and find the energy stuff, there's this newsletter again. I'll go back to that. It has a list of these incentives, okay, for things like fans and all that other stuff. So you can look at that and get a good idea of what might be reasonable for you to invest in. So that's all I will share with you. Again, my name's Drew. My phone number is here and my email. If you do want to reach out to me with any further questions, I'd be more than happy to discuss that with you. So thank you.
We have time for a few questions.
Okay, yeah. So the question was, is there a typical estimated savings following an energy audit? It's going to vary depending on the type of farm. It's highly variable, so I'd be skeptical or hesitant to say a number. I'd say the biggest challenge is actually doing something with it. A number of people get the audit and then they don't actually do anything with that paper. But I mean, it's just so variable that, and you'll get a list of recommendations of things in order that would be a priority for you. So if you did, 1, 2, or 3 of those practices, you could easily save tens of thousands of dollars. It just depends on the size of the operation, the energy system you're talking about. If you're doing a complete LED retrofit, you might be saving. It really just depends on the type of farm and the size. It's hard. I could share some example audits with you, and if you're interested and get an idea. I do have some reports on energy audits and average savings, but it's so variable to say $20,000 savings. Well, farm A might only be $5,000. Farm B might have saved $50,000. It's kind of splitting hairs in different operations.